Right. Let me know once you can see the Word document that I'm opening. So there are a few instructions in parallel you can do while I'm walking through a couple of important basics. This you can actually start doing this registration in parallel. There is something we need to initially register for an account to start our labs as we go.
But we're not seeing anything in there.
Yeah, it's coming up, sir. Yeah, 1 second. You're not able to see the screen at all, or it's opening,
No,
right?
no
Document is
screen
open.
is coming.
Yeah,
No, actually,
document is
we
still
only
opening.
see you. Keshav garu, మిమ్మల్ని చూస్తున్నాను.
ఏమండి?
Yeah, we are only seeing you, but no documents or nothing are coming up.
Not yet, right? Okay, yeah.
Not
So
yet,
that's because it's not yet shared. So yeah, I'm sharing now. Can you see it now?
Yeah.
All right, yeah. So the couple of things that we need to, in parallel, you need to download. One is to download a couple of things, and one is to set up your account. These things are required before we jump into any labs or anything further. But I will cover, while you are doing this in parallel, I will cover some basic stuff that we need to start with. Okay. So again, just to, in case you need to reach me on any email, the same email you can use that I am keeping here. So this document, I will share it. So this will be like a basic thing that you need to keep it for your reference, which will have pretty much what you need to do before class starts. Like, this you could do actually now in parallel. You can go to amazon.quicklabs.com, and it will ask for your, it's kind of a free account only, but once you get in, if you already have Amazon account, but again, this is nothing to do with Amazon, but it's mainly Quick Labs, which is a lot of companies will use this for real-time labs. And if you set up your account for this, there may be a lot of them are free labs also available, but there are some things we need to use with credits, like which is not going to be like one credit is like $1. We may need maximum like maybe 20-30 credits to finish some of our exercises. So, but again, some of them are already free, so nothing to worry. But if something needed, I'll let you know as we go through. That then you can charge your account for the credit, and then that should be fine. So it should not be that much cost there. Okay, but definitely use this link, amazon.com quicklabs.com, amazon.quicklabs.com, and set up that account in parallel. And the other thing I want you to do is, if most of you might have some putty or some tool already, which is mainly like a SSH client. If you need to access any Linux or Unix servers, like in this case, we'll create some EC2 instances for doing the labs. So you should have this tool on your Windows to be able to access that. Okay, so if you just Google it for I can actually put a link if you want. Basically, you can go and look for putty, Google search putty download. There'll be a free download you can find in a lot of places, but maybe you can get it from download putty itself. A free SSH client, Telnet client for Windows. Just download this if you don't have it. Okay, so in my case, I believe I already have it, but let me double check. Otherwise, I will also download that. Yeah, I changed my computer, so I should also do that. Yeah, okay. So while I'm doing, you can continue that as well. Just, let's initiate a couple of these things, so that way it will happen in the back end. Downloads not a problem.
Keshav,
So before you, yeah, go ahead.
this is Durga Ande.
Yeah.
I have a quick question. I'm using Mac, so I can use terminal, right?
I should be able to, but
Because I did a couple of projects in my master's on DBMS, and I did it in terminal. So
yeah, I mean, it generally it's not a problem, but when you get the key, like when let's say we create some EC2 instance for let's say one of the server, it will give a different key for you if it is a Mac. So you have to use that one to pair up.
okay.
Okay, that's the only difference. I think otherwise any client is fine. Putty is something general most people use, so I'm just using that.
Okay.
Yeah, so depends on your operating system. Even in the Windows, look at this, right? If I want to download 32-bit or 64-bit, first you have to make sure what is your machine configuration. Like some machines may be 32-bit if it is old, but most of the new ones will be 64-bit. So I just want you to check that. Let me say, if in my case, if I go to control panel, look at your system security, and let's say my system. So if I see here, my system type 64-bit operating system. So make sure in your settings, in your control panel, system security, where it says 32-bit or 64-bit. So it depends on that. You have to choose your download.
Okay.
Okay. So in my case, I'm going to pick 64-bit. That's putty. It's a small download. It doesn't take much time. So once you have it, just make sure you put it into some place where you can keep all your softwares in one place. So I'll keep it in C drive, AWS training, that where I have. So I'll just put my software also here. Just try to open it and see. Yeah, it should, when you open, you should see the window like this, putty window. Okay, so yeah, not much here. Just make sure you have it. That's all. Because when you start labs, this will be one of the things that we will be using most probably. But definitely, as Durga, I think you have Mac, right? So anyone else have Mac or other tools, still you can use it. There's no problem. So the PPK, the key will be it will be a little different for Mac. So you just need to use that security key. I'll show that when we go to the labs. Okay. So I'm closing that for now. So let me continue with the plan here. So
Kesu గారు వన్ థింగ్ అండి, పటి ఏంటండి ఇది వెరైటీగా ఉంది నాకు. ఇంతకుముందు మన వేరే విండోస్ కి డిఫరెంట్.
it's the same client, sir. Always.
No, before that you don't need to install or anything. Simple, very simple one.
It's simple. Just exe.
కమాండ్ ప్రాంప్ట్ అండి.
Oh, మీరు ఏది తీసుకున్నారండి మీరు? యా,
I want not command prompt. I want Windows one.
యా, విండోస్ 1. ఇక్కడ చూస్తే మీరు ఇప్పుడు నా స్క్రీన్ చూస్తున్నారు మీరు.
It is different. Okay.
So if you see, this is what I mean. You have to see which one you are looking at. It's a client.
Yes.
Yeah, మీరు కమాండ్ లైన్ తీసుకుంటున్నారు.
Okay. Let me try.
Yeah. So yeah, it just a exe. Nothing will no need to install or anything. Just download the exe and that should bring up.
You can also use Mobi extern. That's one other nice one.
Yeah. So there are a lot of tools actually. I mean, even in my document here, I believe I mentioned the other one also. If you prefer that, what is that? The Git. Yeah. Even this one, because I'm just using putty because at least I used long time. I mean, that's mostly I use that everywhere. But a lot of people use this also. If you get the WinGit, right? gitscm.com download. So you get this for Windows also. This is also nice SH client. Okay, but when you download, if you're downloading this one, yeah, you definitely choose to install optional Unix tools. Then it will come. This is another. Let me put since I am here on this page, let me put this link. copy link address and put it here, so it will be easier to. I'll put this document on the Google Drive so everyone can access actually, because this is you are going to refer to this lot. This will have a lot of reference links. Not only this, whatever I'm telling here, like this, some of these downloads, and some additional instructions, and at the end, like you'll see a lot of reference links I put it here. So you can also read a lot of the stuff in your own time. But some of these we are going to review, also look at during our class trainings. There's so many links here, a lot of information to go through. Okay, but again, these are optional, but I would suggest to really go through maybe during the course or maybe after the course, but definitely you should look at a lot of these links. I have put it here in these references, so I'll share this to all. Okay, so now jumping ahead to only thing that I want you to do in parallel while I'm talking, on walking through some of these additional contents. Make sure you have note down on this one. I will put it on our chart here. So in case you need to, where is that?
Nice, Ravi. Did he join? He said he's joining, but I don't know. He's not there.
Are you joining?
He said he's joining, but I don't know.
Okay.
Did you send a link to him Monday?
Yeah, I saw. See, he's there, right? N Motomori, right?
Yeah, Motomori.
Yeah, I already sent it. Yeah.
Yeah, that's fine.
So, yeah, I put a link on the chat window. So you make sure that you click on that. And if you don't have, let me also do. In fact,
we already created account. I created account in parallel.
Already, yeah. Okay, good. So I do have my account in something similar, but I don't think I have to. Let me do that because I have an account on my office setup. So I may have to do this personal now. 1 second. I already did that anyway. Let me try.
Sorry, I'm mute kadandi. I'm on mute kada.
No, I can hear you, but you can be unmuted, sir. Yeah. Quick lapse. No? Happen. Okay. Sure, I had it. Oh, I think I know. I used my other email ID. Yeah. Okay. All right. Okay. Once you get in, you will see something like this. I mean, for me, since I have some things done earlier, you will see something, but otherwise you'll see home with my account, mostly basically once you get in, you should be able to see the catalog, something like this. This catalog will have a lot of labs. I mean, there will be quests also, which will be packaged into like various quests. or individual labs. But basically, like a lot of these things, some of them are like it needs like suppose 10 credits, the first one, but you don't need all of this. A lot of them are free as well. So all the essentials are free. Okay, but there are some special things that we are going to learn that would cost a couple of credits. So whenever we use credits, basically it will take your card, credit card, and it will charge to that. But again, throughout course, I don't think you will go anything beyond 20 or 30. But I would suggest if you're taking credits, instead of taking one by one, maybe take like 40 credits or something, which will give, I think they give some 5% discount on that. That way, around like 30, maybe $35, you'll have 40 credits in your pocket. So even if you use like maybe 20 for the course, but when you have extra credits, you could actually do some extra practice later on as well. Not only these labs, you could do even other things. You can explore a lot of other labs available here. Okay. So again, just make sure you all in this quick labs.
Okay, sir, quick question. We don't have a this question labs. We have start lab is there.
Yeah, because you're first time getting in, so you will see like start lab, right?
You have to click on start lab.
No. You see this icon here, left side, this bar. You will see catalog. Go to that. On the top left corner, next to quick labs.
I see.
Yeah, you go to catalog.
Yeah, then
you will see the list of catalog there, basically, which will have quests and labs both.
Yes, I got it.
Okay, but usually what we are going to pick is not from the quests. You see this labs second tab.
Yeah.
So you click on that. There you will find a lot of individual labs. But again, there will be hundreds of them. Nothing to worry. If you have like a lot of essentials can be learned really free. But only reason why a lot of people don't, because a lot of people don't know which one to use for what. So they need some understanding before they do anything. And also like the quests are meant for mostly, you could take one quest and continue your journey. Suppose you are doing a AWS certification, like a solution architect or something. So there are certain things you have to do as part of a quest. So there will be a lot of labs. And unless you complete all of them in time, they will not consider that you are completed. So that will be useful for certification. So whatever we are doing right now, this will be in your profile. And in fact, later on, if you really wanted to do certification also, all these things will be counted, what you're doing. Okay. And there are so many types of certifications again within the AWS, but we are specializing on big data analytics particularly, which actually they, if you go to Amazon, basically they also say you need to complete essentials first before you come to analytics. But again, there is no hard and fast rule. People, as long as that's what I will bridge some of those things for you, even if you don't have essential, nothing to worry. So I will be able to explain and walk you through. Those are small things, but people expect to have that essentials completed. Okay. All right. So hope if you are ready with all these things right now. So then I'll quickly jump on to my first one. Actually, if you see my course plan, there is one thing that I haven't put here, but I need to cover, as I told in my orientation. I think it is very important to cover that. That's why I want to do that first before we get into any of our course content here. Our course content, if you see, this is what we right. So this is our content. So as per this, basically I have to jump into big data and Hadoop basics. But one thing that what I told is the AWS essentials, right? So when I say essentials, at least you need to be aware of what type of AWS services available and what is the full landscape of AWS in general. So then only you will be able to start. Big data and Hadoop is very important because that's what we are going to learn. But at the same time, since you are doing on AWS, I feel that without knowing anything about AWS also, you might feel a little uncomfortable. So though it is not part of the course, I would like to take a little, a couple of slides just to walk through and explain you and make you familiar with it, and which we will be, because immediately when we get into some of these labs, you will have some surprise otherwise, not knowing what is all the services. Okay. Right. Coming now. That's why this is what I'm going to use here. This is basically, you don't need to really know some of this, but I would recommend to know, because if you want to build your own environment and create your own applications and solutions on the big data, so you should be also aware of how do you do this, your AWS infrastructure. So at least to some level, terminology wise, right? So let me make this big size. Okay. So if you see traditional infrastructure versus Amazon Web Services, this is the biggest, what is the big change, or big difference, right? The traditional infrastructure always, we used to, generally, if you go to any company, right, these are the things you will see generally: firewalls, ACLs, and administrators, they're dealing with the security. And in case of Amazon Web Services, it is a little bit differently managed. It's controlled like firewalls in traditional network infrastructure. You will have something called security groups, and similar to ACLs, you'll have network ACLs here. And how administrators control the authentication and all this stuff, right? Initial user identity, user authorization, and all that. It's all managed through IAM, AWS IAM, which is basically identity authorization management, I believe. Okay. So these are very critical and key components to be aware, and which we will be, some of them we will be doing as well as part of our basic exercises. Because in the traditional infrastructure, you may not need to be aware of networking side of things. What is firewall? What is type of security and all that. But when it comes to Amazon Web Services, it is not like a separate thing. You need to be aware of it because it's a cloud infrastructure. It's like a on-demand type of infrastructure you are maintaining for your own applications. You cannot anymore just separate it. It's a networking thing. I don't care. So you need to be aware of it. Okay. And the security is one thing, and the networking is other thing. On the networking side, we maintain in the traditional infrastructure, you maintain routers and network pipelines, switches, and all that. Like these are all, like, again, no developer really care about this in traditional infrastructure. But when it comes to Amazon Web Services, we kind of put everything into mix. You need to be aware of all these things, because let's say you're building one server or building one Hadoop cluster. You need to be aware of these things, because you need to, though it is not like a rocket science, you need to be aware of what these components are, because you're just going to configure. Basically, you're not going to do anything big stuff here, but what need to be configured, you need to be aware. So in case of networking, ELB, which is basically Elastic Load Balancer, okay, and VPC, virtual private, basically it's cloud, basically virtual private cloud, I believe, right? VPC. So basically whenever you really create your own VPC, you can consider it like it's your own data center. Once you have your own VPC, within that you can have hundreds of servers, hundreds of clusters within that, or you could have multiple VPCs also. But mostly, a lot of companies, small companies at least, they maintain one VPC, but maybe multiple VPCs, one VPC per region. That's how. I mean, again, I'll get into some of those additional details. You don't need to really need to be aware of it, but I'm making you aware of these things because you will be prepared to build your own data centers as needed for your applications. Okay, nobody will question you that whether you know it or not, but you need to be aware. If you want to be successful on AWS infrastructure, you need to be aware of these things. when it comes to servers, on-premise servers, basically we used to have like all the servers on premise before in the traditional infrastructure. You would have a lot of people still use like HP Unix or AIX servers or Linux and any type of lot of on-premise servers, right? So there are so many varieties in that. But now you don't really maintain any physical servers in the cloud. All you have is AMI. It's basically image. Okay, so machine image. What this means, once you have a machine like configured, for example, I say I want 8 CPU. Each CPU, like basically 8 CPU. Let's say I want 16 gig RAM, and I want like 1 terabyte size of hardware. For example, let's say I'm just giving some small example. Once you decide your configuration of your server, what do you need or what do you want, you could make that as an image, and that image can be you don't need to, next time whenever you need to bring up one more node, you don't need to redefine all the parameters. You just simply use this image to get one more instance of the similar server. Okay, so basically EC2 instance here is like a one physical server, one physical. If you consider like a on-premise server line, let's say if you have to create one cluster with the on-premise servers, like let's say you have 100 nodes of Hadoop cluster, right? You might have created 10 different physical servers as a cluster. But here you will basically create EC2 instance image, basically one machine image, and you will spin on. Once you spin off like 100 instances, you can quickly do it without in a short time, very quickly. Okay, and coming to the next layer, storage and databases. So in all the traditional systems, you would basically.
Can I ask a quick question on that? Sorry.
Sure. Yeah. No problem. Go ahead. Yeah. Feel free to stop me whenever you have questions.
AMI, my understanding, but maybe I could be wrong. Clarify me. AMI is virtualization, right? It's a concept of virtualization, right?
It's totally.
Physical server exists. Just virtualization, we are creating multiple.
That's correct. It's a virtual server. You're right. In case of like a Windows or Linux, right? We have a virtual server concept, right? Now virtual, basically even on-premise, nobody is really using physical anymore. They stopped using physical a long time back. Most of the people are using virtual servers now. But that's still on-premise, and physically you are having your physical servers anyway. Like you may be having a big block of capacity, and you are allocating as virtual servers basically for the various teams, right? Still on-premise is using that physical servers, but virtually you are creating like AMI is like a virtual copy basically.
Yeah, I got it. Thank you.
Yeah. It's the same concept. The only difference is cloud brings us so much flexibility and quickness. You can spin off instance like in a split second, like without spending additional time. Yeah. All right. So coming back to storage and database, you see so many types. I mean, basically, like finally everyone sees some RDBMS like Oracle or DB2 or SQL Server. A lot of traditional databases, which is relational database management systems. Behind the scene, it will have NAS storage or SAN storage or dash storage. So these are like various type of storage behind the scene. So that's how people used to maintain how the database is maintained, the storage, right? So now, when it comes to AWS, there is a big difference in how you storage and how you maintain your data and storage. It's totally different now. Well, there are four different, you see here, four different things we're talking here. Amazon EBS, Elastic Block Storage. Okay, EBS, nothing but Elastic Block Storage. This block storage basically gives you, I mean, when you define an instance, right, EC2 instance, you could define how much of size you want as a block. Like why it's called elastic block storage. It can be expanded on the fly. can be, basically scalable, right? And you see EFS. Yeah, let me talk about S3 actually. The most important, then at least for our, it's relevant for our training, and in most cases, the central pillar of AWS services, of entire Amazon services, is S3. So everyone need to be aware of S3, which is kind of behind the scene, how it is managed. They keep it as a trade secret for Amazon success, but behind the scene, nobody tells this truth. But my gut feeling is Amazon S3 is nothing but is a in a Hadoop type of setup. Hadoop, same like HDFS file system type of setup, but Amazon wrapped it into like S3 because it can give you a tolerance of like 99.99999 up to like some tens of nines. That much of uh, reliability. Like you will never lose data once you put into S3. So you don't need to, if it is a hard disk, for example, imagine you are putting something on a hard disk. If your hard disk crash, you lose everything. But the safety, EBS is nothing but like a hard disk, you can call it as. But it can be elastic, it can be expandable easily, but still it is like a hard disk. But when it comes to S3, like you keep one copy, but behind the scene they will have hundreds of copies redundancy, and you will never lose it. And how it is managed, it is totally behind the scene. It is using something very similar to HDFS file system, like Hadoop distributed file system. But Amazon never says that it is using HDFS behind the scene, but it came up with a new terminology called S3. And they say S3 is our core storage area, the primary storage area, and that is the central component for the entire Amazon AWS services. For all of them, without S3, there is no solution in AWS, I can say.
Yeah, Keshagar, one quick question on that. Sorry if you're done this or ask. I already know, but this reliability comes into the beginning. Now, most of the time, currently in the database also, we have concept called replication. So in the real time, it will be replicated in the different region.
Right.
Then one's machine is not available for crash, the data is available on the other server. Yeah. So that reliable, the replication engine takes care of it. How it is different? Why only S3? How the S3 is different from replication engines that we are seeing in the traditional databases?
I will reserve that for a few minutes. That question. That's an interesting question. The reason why I want to reserve that, I want to give you a difference in the example that you told. Like you could replicate, and you will have your own copies, right? That's one way of keeping more reliability. And the second way of is that's where why HDFS or Hadoop file system came into picture in the first place. I'll explain that. So when I explain that, you will know why replication is not a solution for that type of scenarios. Why HDFS is the difference. Once you understand the difference, then the difference between HDFS and S3, there are some additional differences as well. So I want to compare like a general way of replicating yourself and keeping it various copies and maintaining it versus how it is maintained in Hadoop distributed file system, the way of storage and maintaining, and how in S3 it is different than all these two. So there are.
S3, I agree. Elasticity is there. Elastic component is there.
Yeah. Not only elasticity. Not only elasticity. So let's reserve that. The reason for that, when I go to Hadoop basics, right, which is coming today itself, I'll start on that. So this will be maybe one of the questions that you will have much clarity on that. I'll explain those differences when I reach there. It will be here soon. Okay. That's one thing. And Amazon RDS is also like this is basically RDS is nothing but just to be everyone aware. It's basically a relational data source. Amazon created a wrapper kind of RDS. Underlying that RDS, it could be any database. For example, Amazon RDS could be based on Oracle database. It could be based on SQL Server database. It could be DB2. It could be any general RDBMS database. But when it comes to Amazon, they make it like a database as service. You might be hearing like platform, like, right? So platform, infrastructure as service, platform as service, database as service, all this terminology. IaaS, PaaS, and DaaS, yeah, all these terminology people talk about. The Amazon RDS is just nothing but it's a database as service. That means you will not really have Oracle database like a database setup. You don't create one server and set up all that. You will simply configure Amazon RDS with your same Oracle licenses. Behind the scene, hardware is maintained by Amazon, and you will not really physically look at what is my server and basically a lot of administrative things that you do with the general database. For example, taking backups or maintaining some schedules. The lot of DBA stuff is taken out of your burden. The reason for that, Amazon RDS will provide as a service. You just call this service, I need the database service, that's it. And what database service is really you need for your application, you want to be able to execute your queries and whatever required from your SQL interface. So once you connect to Amazon RDS, behind the scene, it could be any database configured, and you get the service you need. You don't need to worry about what type of Unix server, Linux server, or what it is and all that. You can define, but you don't need to worry about it. And no maintenance, like suppose you don't need to. Generally, database, most of the time, you keep on changing your and apply this patch, that version, this one. Continuous maintenance will be there always. So that will be taken out. And Amazon take care of all of that. Okay, it's like a ready-made service. And yeah, advantages and benefits of cloud computing. I mean, this is something everyone would know, but just wanted to explicitly mention here. Trade capital expense for flexible expense, right? And the benefits from massive economies of scale. Eliminate guessing on your capacity needs. Because otherwise, earlier, if you have to do your capacity planning for your infrastructure or data centers, it is really a guessing game. No one had clue how much of capacity you need upfront. It's always like you try something, oh, it isn't enough, it's not enough. You again, the procurement of that servers and ordering some. Let's say I assume that my capacity is good. Sometimes just to be safe, you order a lot more than what you need, because it takes a lot of time to procure that infrastructure. Otherwise, most of the companies do that. At the same time, if you want to be cost conscious, then you will reduce. Then you are losing time when you need to increase the capacity, because when you order, it takes so many weeks or months sometimes to get them into data center and set up. Right. So and the can you hold on a second? 1 second, please. Yeah, sorry about that. Okay, so increase speed and agility.
Okay, so just one first point: trade capital expense was flexible expense. So you need a capital expenditure to buy a hardware. Instead of that, you on demand you're paying flexible expense. That's what
that's exactly it is. Flexible expense is nothing but you pay as you go. You don't pay upfront and make it as your capital expense.
Yeah. Okay, got it. Sorry.
That's the biggest difference. You're right. Yeah. And the speed and agility, basically this is another biggest factor, right? If I want to increase the capacity in the traditional infrastructure, you take like a number of weeks, and it's a big process to procure, as I explained earlier. But that's all become so simple now, and it happens very quickly, and you don't even lose any time because of infrastructure procurement or increasing capacity. And stop spending money on running and maintaining data centers. This is another biggest thing. So not only just servers, right? You buy servers and all, but to maintain that, you have to have like your own buildings and a lot of energy power, AC units, and so many all expenditure, that overheads that you today you pay on your infrastructure and data centers, all that is taken out. It's all going under your pay as you go, right? I mean, again, you're not really getting free, but if you compare with what we do generally for our data center maintenance, it'll be like a tremendous difference. You'll see so much dollar saving. Okay, and go global in minutes. This is another biggest thing. Suppose having a data center of your own. Today you might have US operations, tomorrow you want to go to Asia Pac or somewhere in Europe. So it's like a big hassle to really find a location, find a right place, and procure all your infrastructure. It's like a massive effort. And now if you decide to go to APAC or Europe, just in minutes, once you have your setup here, you just simply get a similar setup in another region just within minutes. So that easier. Now, sorry, I think I need to, yeah. This, can you see this? This is a little small picture. That's why I expanded it. You all know, like mostly Gartner create the quadrant for in each area, right? Generally, they try to look at who are the challengers and leaders and niche players and visionaries and all that. So usually in every area they do that, and this is where, if you see, I think yesterday someone asking like how you compare this with Microsoft Azure and Google or other services, right, on the similar cloud infrastructure. If you see, as of now, really only Microsoft and Amazon are in the leaderboard. Everyone else, including Google, is somewhere out. So you can't even see anywhere. And there are a lot of other places. I suppose in my previous project we used CenturyLink, but that's nowhere near to AWS, right? But they also maintain cloud infrastructure. But it doesn't mean that they are like leaders, especially because of kind of flexibility and the type of the tools they provide and the agility they provide. This is just for your information. And coming down to this AWS cloud computing, this will give you a quick picture of like what type of differences, because some of this will start touching of what we are going to do in our big data solutions. You see here, this is application layer where you will have virtual desktops and collaboration sharing type of things, and where you have platform services in between. There are foundation services, there are infrastructure. So these are like various layers in the AWS computing, the way your infrastructure setup. Generally, infrastructure means nothing but like you define your regions, you define your availability zones. Within each region, you could have multiple availability zones. So that means I could have multiple availability zones, because usually if one thing gone, like let's say US East, I might have zone 1, zone 2, zone 3. If one thing is gone, the other thing is available. So you never lose. It's basically redundancy, but it is availability purpose. And edge locations is something a new concept in AWS. They call this as a content delivery platform. Edge locations is nothing but Amazon itself set up a lot of locations across the globe as edge locations, not for the purpose of like setting up data centers like we have regions and availability zones on AWS, which are still limited to more on the US East Coast and some of the areas. These data centers are provided in the cloud infrastructure. But edge locations is like across globe, but it's mainly meant for some like static content. Suppose in the website, right, some people might have static content. So you don't need to really, that can be, it's like a lightweight, and it is available in all the, it's like a cloud front. People call it as a cloud front. In your web infrastructure today, a lot of people push some of the content to the cloud front, which means all that cloud front content is actually sitting in the edge locations. The reason for that, you are making it more accessible for somebody in Singapore or Thailand, somewhere. if they have to come and access your content, if the content is sitting in somewhere US, East Coast, New York, or somewhere, there is always some latency. But a lot of data, which is content that is more static, and it doesn't need to really always go back and forth through the data centers. So it can sit on these edge locations. It is immediately accessible for any location nearest to that edge location. So that is some new concept they introduced to minimize. This is more of efficiencies of how you maintain content. So that's something not many people leverage at this point, but it is gaining momentum now in the AWS world. Coming to foundation services. So see these verticals here. Why I'm showing some of these documents for you right now. There are components, very important. Some of these things I will be talking when we are doing the exercises, and you should not surprise why this and why all this. I mean, again, you may not use a lot of this I'm showing here. It's like a really broader and very high level picture of so many things. You may not use everything. We will use some of this, but I want you to be aware what all things available, and then we will touch deep into what we use. Okay. And Amazon EC2 is a basic thing, which is like a EC2 instance, you can call it as one server, right? If you create one instance, that is one server. And AWS Lambda we are going to use, which I will call it as like a more central piece for the serverless architecture. When I say serverless architecture, AWS is introducing nowadays, this is more popular now. They say for most of the things you do in your organization, you don't need infrastructure at all. You don't need a server. When I say server, don't think physically server. You don't need infrastructure. Even if you are doing it on cloud, you're basically having infrastructure, right? But what they say, for most of the stuff we do in our organization day to day, you don't even need to have infrastructure. The reason for that, AWS created something called AWS Lambda environment, which will basically have some functions like a framework. That framework, you can simply create whatever functions in Python or JavaScript or something. Basically, in your organization, some of the times, if you see, you will do some computation, basically, right? That computation, if you know what function you want to do, you just submit that computation to this. It will go and get the results for you. It will get the calculation done for you, computation done, but you don't care where it is done. You don't care really how many servers I need to have this this process or this computation to happen. You don't really worry about any capacity planning or anything. So literally it's going against a serverless architecture. Okay, so that's I'll jump into that a little more later, but here I will not spend much time. That's something very useful and important. Amazon EC2 container service, elastic load balancing. This is also very useful. Elastic bin stack, auto scaling. So auto scaling is one of the best feature of maintaining scalability. Like you could actually automate your scalability. Depends on the load and depends on the needs. It can scale up, scale down, scale out, everything can be possible. Just everything automatically. And that, of course, it won't happen automatically without creating. That's where we use some of these Lambda functions and things like that to identify some of the triggers and make them automated. Very simple with small techniques. Okay, on the network side, the most important thing need to be aware, everyone, VPC. It's like a data center. Think of that as a data center. Okay, and Amazon Route 53. This is nothing but this is where it's all your in the networking type of routing, basically. Okay, the direct connect. This is mainly people use when there is a solution. When I say hybrid architecture, most of the companies in the transition right now, they still have a lot of infrastructure sitting on-premise. Servers and so many web servers or database servers, and sometimes data warehouse. At least data warehouse is one of the heavy duty one. Nobody want to move that. It's a huge thing into a cloud data center. They still keep it for into on-premise. A lot of companies still doing that. Reason for that, it's first of all heavy, high volume data, and it will be very expensive. And people want to have security more, not confident about cloud security, keeping it on public cloud or in a private cloud like this. They wanted to keep it on-premise for the compliance reasons and a lot of various factors. Okay, when we have such on-premise setup still, but you are building your analytics and a lot of other stuff on AWS, how do you move data across? Sometimes you may have to use the on-premise server. Sometimes you have to use the AWS infrastructure. So you might have a lot of back and forth happening between these two hybrid like in a hybrid architecture. So AWS Direct Connect will help basically give you a direct connect, which is basically some fiber setup, right, in the fiber network or whatever between data center, like between Amazon data center where we have our AWS setup and to our on-premise setup. So they give you a direct connect. So it will have a high bandwidth and you will not see any difference as if like it's on-premise. You'll feel like no difference whether it's on-premise or on cloud. So this is one thing that heavily used in most. Suppose if I'm working in Verizon now, we do have direct connect between Verizon data center to AWS cloud. Like we have a direct pipeline, like a fiber network exclusively set up for us because Verizon itself is a network provider. So in fact, most of the AWS data centers or Amazon data centers are fibered by Verizon. So we use that. Okay, and storage. This is where, as I told, S3, Amazon CloudFront, which I mentioned about the static content. Mostly all the Amazon CloudFront, all the static content people are trying to put it into Amazon CloudFront, which is generally hosted in the edge locations. Amazon Glacier, which is more like in the olden days, people used to take backups in the tape backup. Like if you something, old data, and after 10 years, 5 years, nobody cares, but you still want to keep it for, audit purpose or compliance reasons. So you tape all of them and you put all your big tapes into some, cold storage. And whenever you need, it's like a painful stuff to bring the tape data back to normal system, because somebody has to go and find physically where is the tape and bring that back and bring it into system and reprocess and all that. So it's a painful, it takes weeks sometimes to get that type of backup. Now Amazon Glacier is really meant for cold storage. S3 is for hot storage. Hot means the data that you are currently using, you use it in S3. But anything that is becoming old and not regularly used, once in a while, you move it to Glacier, which means the reason for that, why they move it to Glacier, it's very similar to S3, but the cost, if you see, if S3 is, let's say, if it takes 10 cents per, for KB for something, then in Glacier, it may be 1/10 of it. So it's so cheap. So you don't need to keep all the data in S3 when you don't need to use that. Let's say I have something yearly report or something. You don't need to really keep it here and keep paying money for that storage. You put it into Glacier because Glacier is nothing but like only thing, it is not directly available. Whenever you need, it will come in a couple of hours. It's not like a couple of weeks like tapes. But the reason for why it takes a couple of hours also, it's basically you send a request that you wanted to use this data, they will move the data into S3. That's all. But it's a less cost storage location. It's a kind of a S3 to low cost. Okay, meant for historical or archival purpose. Amazon Elastic File System, Amazon AWS Storage Gateway. So a lot of these things, right? Everything has its own significance. Why? But everything they call it as AWS service. Okay, and we may not need to go into every single thing here unless you are really like a solution architect who is designing the entire infrastructure for data centers. You don't need to really worry. But I would keep that as more like optional for you all. But I'm touching all this to make you aware of the services. Okay, this import export also. Mainly we might use, not most of the projects people use this. Reason for that, when you are moving from regular infrastructure to AWS infrastructure, you might have a lot of data movement, initial data loads first time. Going forward, everything may be collected on AWS in S3, But initially, a lot of data you might have it on your on-premise, so you have to do import exports. When you use that, you could be able to import from on-premise to on-cloud to on-premise, so that will help the tool. Mostly for initial data loads, that's what used.
Basically, DynamoDB is part of the storage also, right? DynamoDB is.
DynamoDB, I would call it as a kind of one of type of database, NoSQL database.
Yeah, but it's part of storage.
It is not storage. That is where the difference. None of the database are storage. Even regular databases, you should never think that as a storage. Database is now a system, RDB, relational database management system, is giving you a mechanism of accessing the data or organizing the data, but the data is not stored in Oracle itself.
It's on a hard disk anyway. It's file system.
Yeah, it is underlying. It's a NAS or SAN or some storage basically. Similarly, here Amazon DynamoDB is like a NoSQL database. Behind the scene, it will store the data under some S3 buckets or some HDFS file system.
Okay, got it. Thank you.
Yeah. Okay. Mostly any NoSQL databases, it is on top of HDFS file system. So behind the scene, NoSQL database is a layer on top of HDFS file system. You can think of that way. And Amazon NoSQL database is nothing but DynamoDB. That's their database, just like MongoDB, the open source. Okay. Security and identity. AWS identity access management. This is a really critical part because going to cloud, most people worry till today. Even if Amazon is so secured and so well managed, well controlled environment, otherwise company like Verizon or even financial companies, some of the big companies going into AWS is not a joke, because the privacy and the security and identity, a lot of this stuff is very big thing for companies, especially for the reputation risk and data security purpose. But they're all, until unless they feel very confident, they will not able to move here. And imagine that companies like this are going, and how robust the security and identity mechanism is. And it's such an important factor for a lot of people. Still a lot of people not convinced, oh, if I go to cloud, I may not be secure. Somebody might easily hack it and do things. So but AWS security, once you get in, you unbelievable security. Like even Amazon itself cannot crack it. If once you set up your own things, you have full control on your security, and not even Amazon can get you back if you lose something. So it's such a robust one. And it has various things like AWS Directory Service. This is something like LDAP, in regular words, LDAP, or a lot of like directory services, right? AWS KMS is a key management system. AWS search system and WF. So some of this stuff even I haven't used, but I would call them as more of like a all related to security and identity related services. Okay, but you may or may not use everything, but at least these three definitely you will use, very common. But the other two is more like optional. I would call them more of a some advanced things. So even I haven't gone to that. Applications generally like any other Microsoft Office or Google Docs or Google, all these. Basically, Amazon has its own. It has work docs, workspaces, workmail. Very simple. Workmail is like a Outlook or a Gmail. Workspace is like a Office type of setup. And the work docs is like Word doc and Excel sheets type of thing. So these are all standard services. That's why it's called foundation services. If you go to any AWS environment, whether in at least one component from each of these area, compute, network, storage, security, application, people will be using as a foundation service. Now, platform services. Here, some gears will be shifted. We have to be aware. Here, some of the interesting topics will come. Databases, analytics, app services, management tools, developer tools, mobile services, Internet of Things. Why I am showing all these like various classifications? If you go to AWS services right now and open look at, there are hundreds of services. You will have no clue what is being used for what purpose. So at least my slides here, what I'm sharing, should help you to figure out, oh, RDS means it's something related to database. If you say AWS Cloud Formation means, oh, it's something like management tool, right? So you'll have some classification here to figure out what is being used for what purposes at a higher level. So at least first two, I want you to focus on these two. At least the other things, this management tools will come more into DevOps type of setup, like people who do a lot of automation. Cloud formation is the key. Okay, I'll get into some of those details when we do cloud trail, and a lot of this stuff will come into like more automation type of stuff. And developer tools is like more code version control. Suppose you have like CVS and a lot of version control managements people used to do, that will come into this, like code deployments and things like that. Yeah, I'll leave this section separately, but I will stick with the first two as main areas that we need relevant for our course. Amazon RDS, we may not use that much, because even if we use, it will be like one of the source, because RDS is like a Oracle or SQL, any existing database. There is no difference here other than it is a service. You don't need to really physically have server setup and all that to maintain your Oracle database in Amazon. I can simply make it as a RDS instance, and that will be used for my service. And Amazon DynamoDB, this is where we have some interest, because this is related to big data family. When I say big data family, NoSQL database itself is a word that came as part of big data and Hadoop ecosystems. So that NoSQL database, Amazon DynamoDB is one of the NoSQL database. That's why we will be touching that as part of our course, and we will go through. Amazon Elastic Cache. Elastic Cache is nothing but like a in-memory. A lot of people you might be seeing in-memory databases, in-memory. Suppose Spark, in the Hadoop terminology, a lot of people use Spark, right? So how do you maintain your in-memory? Basically, Elastic Cache will be the behind the scene. That's the component. And Amazon Redshift. This is exactly like a if you are aware of MPP databases, what I mean is multi-parallel processing databases. Like MPP database is nothing but like meant for data warehouses, I would say, in simple words, like Netezza or Teradata. We used to have even Oracle Exadata. So all these are like more of a data meant for data warehouses, that type of databases. They're not regular databases like Oracle or Microsoft SQL Server or DB2. Okay. In the similar way, Amazon has its own service. It's called Amazon Redshift. It is also like a database as service, but this database is not meant for regular database. Like Amazon RDS is meant for regular database. Amazon Redshift, its own product for Amazon to cater the needs of data warehouse. Just like somebody having Netezza or Teradata, they could easily migrate to Redshift now, if they want to stick with the Amazon platform. Or still they can continue to have their Netezza Teradata on their on-premise. There is no hard and fast rule. They don't need to bring it to Amazon. But if they want to bring it, they recommend to bring it to Redshift, so that everything is in your regular database application, web server, everything, your Hadoop data lake, your data warehouse, everything. And you might question actually why data lake, data warehouse is still required when you have a data lake, Hadoop data lake setup. So we'll go to that also. There is a lot of difference between data warehouse and data lake. Why we create Hadoop data lakes. Right, so AWS database migration service. If somebody having some database already, like if they want to migrate to RDS or Redshift like that, so this migration service will help. In the analytics area, so this is where our final end goals, right? How we bring the data and how we manage into our database, available AWS databases. Not everything will fit into one. Some things may fit into RDS, some things may fit into DynamoDB, some things may fit into Redshift, some things may fit into Elastic Cache. So depends on what type of data, where we want to maintain, organize, we will choose that. But when it comes to analytics, we have something called Amazon EMR. This is our core area. Amazon EMR is something that equivalent to any other Hadoop environment, like Cloudera or Hortonworks or MapR. There's so many other tools out there. So the Amazon EMR is a purely, it's elastic map reduce, that terminology wise, and which is meant for analytics. And this is where we create our HDFS file system on this EMR environment. Okay, and AWS data pipeline. This is something that how we ingest the data. Data pipeline is one of the service we use. That means how you bring the data from external sources into Amazon AMR. We use a data pipeline there. Amazon Elasticsearch service. This is it's like a search service on the for the purpose of, like, it's like a Google search, Google Analytics, for example. It's something similar. Amazon machine learning, which is like a standard machine learning terminology, but Amazon put his the own name, like Amazon machine learning. It's basically a subset or maybe superset of machine learning libraries. There are so many open source machine learning libraries out there from Apache Foundation itself. But Amazon has picked up, some of the libraries and wrap around and say, oh, these are all Amazon machine learning libraries, which will have pretty much everything generally we use. If more advanced things required, you always have flexibility to use any machine learning libraries. Okay, Amazon Kinesis. Kinesis is something is meant for streaming purpose. So whenever you have a need of streaming data, so Amazon Kinesis will help there. So to help stream the data from sources into Amazon EMR. So these are the core things. We will do some of the exercise definitely in all of these areas, especially the first two areas. So as we get into the deep dive, okay. And I'm not talking about Internet of Things at all, because this is something very new. And again, though it is new, it is nothing different. If you want to build your data lake in Amazon EMR or any Hadoop system, the source could be anything. It could be a standard Oracle database, or it could be a flat file, something coming from FTP, or it could be some XML feed. It could be any type of data, and it could be even a sensor data or web logs or Twitter feed. It could be any type of data coming in. But now the new additional thing that could happen, IoT device, anything that is connected, Internet of Thing, anything a connected device could be your source. And it's not like a file or something, anything like a IoT, it could be some sensor, or or some device that may be continuously producing some data. You don't need to really have like a file or database to collect that and put it into data lake separately. You can actually directly use that as a source, your IoT. You configure your IoT device as your source, and whatever it's producing, it will directly pump into your Amazon EMR. Okay, that's the capability, but it needs some configuration to do. Depends on what type of IoT, the device that you're going to have as a source. Okay, that's a little bit advanced. I haven't even tried, but in theory it works. And it's been tested by, it's being more popular now, because more and more data sources are becoming IoT devices, including sensors, and a lot of sensors, especially in manufacturing and pharma and healthcare, telecom, everywhere. So much going on, because you don't need to really have something to collect and something to parse. That device itself will produce, and it'll directly go into Amazon EMR. Okay. All right. So don't want to bore you with so many icons and colorful things here, but still, again, this is another way of categorizing things, right? Administration and security, all stuff we put into one block, and application services, management tools, mobile. This is like a superset of so many things. Okay, I will share some of these slides with you all, you guys, but keep it as your reference. But don't lose or don't lost with this why all this and all. Okay, you will figure out very soon once you start using Amazon AWS platform. You will start liking and loving to start leveraging all these things, in one or the other places, because you will, if you once start this journey of AWS, endless, like there are so many things to learn, and there is nothing harm learning more, and everything could help in one or the other way. Actually, let me go back quickly once. I forgot to mention one thing in the analytics. Don't worry about anything else. Just look at only these two areas that I want you to figure out, because this is where our scope is. You see that artificial intelligence and analytics, there are two areas. Those two, I want you to be little bit familiar. Basically, even some of these, if you ask me, I haven't get into that much deep into artificial intelligence, but I have done some good enough things in machine learning area, recognition, poly, lex, and there are even fuzzy logic. There are a lot of other things coming in into the every day, something new coming, basically. Okay, all these are related to the artificial intelligence. This is where a lot of mathematicians and all that, like, spending a lot of time here. There are so many things coming every day, so I'm not up to date on some of these things, but we will focus on machine learning, at least in our training, which is the core subject, at least we have to be aware of. And as you enhance your skills, you should be able to expand to all these and be familiar with. Okay, on the analytics side, again, elastic MapReduce is the main thing that we go, and even cloud search to some extent, basically the elastic search and cloud search areas, because that's something like a text analytics, like search analytics. Okay, and kinesis also is something important, because the streaming data is becoming more and more prominent, and we all need to be aware. And the data pipeline we already talked about, and the one thing that I haven't talked about is QuickSight. This is exactly the alternative, a BI tool or a data visualization tool from Amazon, something equivalent to ClickView or Tableau or something, a lot of other BI tools out there for data visualization. Amazon came up with its own tool now. Okay, we will be able to do some exercise on this at the end, but again, our logical steps are, we need to understand how we collect the data, how we process the data, and then how we create some of these predictive models using machine learning, and how we analyze or visualize this data on the end BI tools. Okay, so there is a layer of things that we have to go through in next couple of weeks. So that is where our focus will be. Again, this slide is, I think I can skip it. This is just where exactly these edge locations are. As I told, there are 16 AWS regions for the cloud infrastructure. There are 42 availability zones, and 5 more availability zones coming in, 2 more regions coming, it seems. And this is like a what AWS has currently, basically. Okay, and these are edge locations. Sorry, I messed up. This is the existing global infrastructure where AWS regions are. If you see, a lot of them in here, North Virginia and Ohio, you see here. So the big chunk here only, 5 plus 3 in East Coast. That's why US East is one of the big one for AWS regions. Edge locations are a lot of clusters there. So there are 64 plus. Okay, so this is one small slide here to remember everyone. AWS is a shared responsibility model. Okay, the reason for that, we may not care. If you see here, right, the quick check here, what is our responsibility versus what is AWS responsibility, because a lot of things AWS says everything is a service, you don't need to worry, but there are some things still our responsibility. Okay. So if anyone can guess, what would be our responsibility out of these blocks? Is network our responsibility or AWS responsibility?
It is still our responsibility.
Application.
Let's take a chance here, right? So application is our responsibility or AWS responsibility?
Ours.
That's definitely ours, right? So network is, I think, yeah, Om already answered that. And user data, what is
Yeah,
that one? User data is AWS? No.
Our
our
side,
responsibility.
it is both. It is both. How you secure, you have to secure as a layer, as AWS. Security is their privacy. Security is important because no one is hacking their system and taking my data. Yes, it is our responsibility to make sure you have the proper entitlements and proper security implemented as part of your application process.
Right. I think it's still our responsibility at a higher level. But you're right. I mean, if you go to deep dive, definitely there are some areas it is mixed a little bit. But let's see, just in general, right? If you see here, physical, definitely AWS responsibility, because that is what AWS is telling. Don't worry about what is physically you have. That's taken care. Network, don't worry about it because we take care of it, right? Basically, some of the thing that we used to do in the traditional infrastructure setup, we used to worry so much about these things. Now we don't need to, because AWS as a platform, it takes care of most of the stuff, that all the physical things and the network things, the hypervisor, and the real thing that you are guest OS is your responsibility, because you have to tell you want a Linux server or Windows server. Basically, when I say, you have to define, right? Because for your applications you want Linux or you want Windows servers, so that you have to still define. That's your responsibility. Application is yours, data is yours. So basically, if you see, out of these three, the all the heavy stuff is taken care by AWS. You don't need to worry anymore. So from operating system, it's your responsibility. You define your operating system, you define your application, you define your user data. Okay. But when it comes to security, the one that what you mentioned, user data is, in this context, user data is like what data you want to put into your application. Is that the user data, not the security, users security stuff we're talking here. Okay. So again, elastic compute, EC2 here, relational database. That's how we generally manage currently. How these things are taken care of. EC2 is taking care of all these things: hypervisor, network, physical, and all that. Once you spin off your EC2 instance, all this is taken care automatically. We don't care really. And once you just spin off one RDS instance, all this is taken care. So now, shared responsibility. So the reason why I showed earlier, it's a shared responsibility model, right? You can create different ways of shared model. Suppose if I don't want to even maintain my guest operating system and application, you can give that to RDS. The difference here, your RDS can be your own. Like you can say, I want Oracle, I want Linux operating system. Here, when I say guest OS, it's Linux, application is Oracle, right? That's how I'm maintaining here. So here I can say my like Amazon Relational Database Service RDS, I don't need to care, except user data. I don't want to worry anything. If you use RDS, that's the advantage. Then general database, you have to use that. Your responsibility generally. That's the biggest difference now. It's like a service, managed service. That's it. I think I'll stop here for we are crossed like a little bit. Then I wanted to stop that at 9:30, but I went over like 30 minutes because we started a little late, 20 minutes, and I may little overrun. But I'll try to stop at 10:30 because I know everyone has to go to work, and definitely next few days, first day generally I want to get everyone get more understanding on what we are using as a platform, so that will help you to get to the to set the stage for our some of the exercise and things like that. Okay, so now I will jump into the actual course content quickly, and maybe we'll do one exercise to start with. Let me see what is in the program here is. So basically, I'm supposed to cover some concepts of big data and Hadoop basics, which I can start even tomorrow, because that will take some more additional, at least another hour. So which I will keep it for tomorrow. But today we will directly jump into start looking at the environment, see how we can, without even knowing what is big data and what is big data solutions and all that, right? Though you don't know, maybe since you are aware of the platform now, we can at least play with DynamoDB and see what's happening and how things are happening, to just to get your hands dirty a little bit. Okay, and then we can talk about tomorrow. I'll cover like 1 hour on some of these basics, and then we can do some additional labs on that, and we can focus. Maybe I'll cover both in next one. Okay, slowly I have to catch up some of these things. I know this 30 minutes will keep on going every day, but I'll try to minimize somewhere. Okay, now, so if you all get on to the everyone already had account, right? So lab catalog. Here, go to labs and search for I don't think you will have exactly same, but let me try first, because this they keep changing these versions of labs. I will say storing and querying. It may not be same exactly right now. Yeah, I don't find that. Okay, fine. It says DynamoDB simply. Let's see. Basically, I want you to get familiar with DynamoDB. Though you don't know any basics of what is DynamoDB, all you know is at this point right now, it is one of the NoSQL database, right? And what is NoSQL database and how it is different from regular database, I'm going to cover that in my Big Data Hadoop basics tomorrow. I'm supposed to start that today, but I didn't do. But I'll cover that tomorrow, because that's a little deep. We have to go into that, some of the basics. Okay, so let me search here. I'm sure you should get something. I'm sure this is a free exercise. Don't need to pay any credits, at least for today.
It's like introduction to Amazon DynamoDB. Is that the one you said?
That's free, or yeah, that's the one.
Free.
Exactly. Yeah, that's it. Yeah, that's good enough. I mean, there are a lot other things you could do on DynamoDB later on if you really see. The good part is these labs are real time, and they are available anytime on demand. But only thing is, it costs, some of them cost like suppose 8 credits, 10 credits, right? So as you go more advanced, some things will cost, but again, it is always worth to do when you really need something. Otherwise, suppose DynamoDB, I don't know how much of you really need to use, but if you go to any environment, at least you need to be aware of DynamoDB. If you go to Big Data Solutions, you may not use always, but you need to be familiar with it. And then tomorrow when I explain some of the concepts, you will understand how it play a role in Big Data Solutions. Okay, so for that reason, I want to start this. Since it is a free, you could definitely get onto that. So before you do anything, I want you to give some. Since this is free, you don't need to worry too much. You click multiple times, 10 times, it doesn't matter. But things that are with credits, use it carefully, and it is all timed. Like once you start the lab, it will be live only 40 minutes. Okay, and especially when you start the labs first time, it will take a while for you to understand the instructions that are given. But here at least what I will do, I can walk through and help you if you are stuck on some of the issues. And generally people get stuck in how I do this, how I do, though it's all something very clear, but checking with the environment, you will have some troubles. So at least for the first time, this exercise, when I start, you see a few minutes of initial until you enter into the exercise, then you start, because some people may not be even especially with some people, OPT people, right? I see in our class today, I don't know if they ever used putty, for example. Putty is like very common, but some of these things, I will show first time. So then later on, any lab you see, it's a very similar things. Okay. So if you want, you can start parallel if you're comfortable, and if you're stuck, you can, we can, you can ask me, and we can share the screen and do things. But otherwise, I would suggest, instead of before you start, you can start anyway. Suppose after 10:30 also, if you have time, you can continue also. There's nothing wrong today itself. Okay, but if you see, at least you will know something you don't under. My sincere suggestion on these trainings, right? All the labs, especially, one biggest drawback is they give nice instructions, and you see each instruction. Oh, okay, click here, click here, click here, click here. You do. Finally, you'll do everything. Oh, you'll see. Oh, it worked exactly like they gave. That is no fun. The reason for that, it will work because they give instructions and you click this, and you will get it. But you will never have a clue of why you did that and what are you doing there and what are you achieving. So I want you to spend good amount of time to understand the problem, and or not problem, actually, what you're trying to achieve with this lab, right? And in what way, what steps you are taking to achieve that. So, and again, because the time is limited, it feels like a rush a little bit. But especially if it is free, I would ask you to do multiple times, and until you it stick in your mind that today if I ask you to do using instructions, first time you do it, no problem, using follow instructions, do it. But next time, if I give you the same exercise, you should be able to do blindly without seeing any instructions. Then that means you are really getting it. So that's what I want you to really insist, because most of the trainings, at least in my experience, including Amazon, when I went, they make you do all these labs, you do it, but end of the day, you don't know what you did and why you did. And you will finish your training and go. But this is where I want to insist everyone to make sure you do whatever lab. First time, I don't mind. You do follow properly instructions and do exactly what they say. But definitely repeat the exercise next time without following the instructions. Then you will learn. Okay, because it's a completely new environment and first time you guys doing, so I don't see any problem in even in, if you know, I would always suggest to follow instructions for first time, first iteration. In the second iteration, do without following instructions, because I'll tell you, for example, here, right? If you go to contents here for this one, without even starting my lab, right? I'm not starting yet. If I see here, I see completely the purpose of here. This lab is really given here. I mean, you can actually click on these things and see. If I see at a high level, the lab overview, I can see what is happening and what is the DynamoDB, the AWS console, verify your region in the AWS manage, creating a new table, adding and modifying table data, modify an existing item in the table, querying the table, deleting the table. And if I go here, right? First, don't start the lab first. Look at this, what we are trying to achieve here, right? The lab overview is, we will create a simple table in Amazon DynamoDB to store the information about music library, including the artist name, song, and album titles. Because believe me, anything you do in big data solutions, if you don't know what data you are dealing with and you don't know what use case you are trying to achieve, it will not have any meaning, whatever you learn technology wise. It has to be always relevant to the context and the data. Okay, make a habit to looking at the data and looking at the context always. That's an important characteristic you have to develop when you're in an analytics space. Okay. So this purpose, really, we are trying to have, get there is a lot of information about music library, and including artist name, song, album titles, and the year of release and such things. So you will then query the music library and finally delete the table. So basically, all you're trying to do here at a simple statement here, how to use DynamoDB to store the information about music library and all the information about it, and how to query it, and how to do some basic search and query things, and then finally delete the data table. So once you know how to do that for one table, then in a real project, when you have like hundreds of tables coming and you need to use DynamoDB, it's no different once you learn for one table. But the question is, why you need to use DynamoDB, why it cannot be in Oracle, why it cannot be in a Hive database, something else. So there are so many ways of storing and organizing the data. Why it should be only in DynamoDB? That will be a key factor for you to learn. Because when you go to a project, nobody will tell you, oh, you store this table in DynamoDB, you store this table in Oracle, you store this table in HDFS. Nobody will tell you that way. You have to be on your own and justify yourself what makes sense where. And you should be in a position to guide your client why you're doing that, and the reasons for doing such that way. Okay, that is what you will learn. So generally these labs are, it's not a rocket science. Everyone can do this. Again, some of them are even free, right? Why not everyone can become an expert in these areas? Because nobody will connect these dots for you, like why you're doing this and what, when you need to do what, all that stuff. That's where you need some guidance from instructors and trainings. Otherwise, Amazon, everything is free. Actually, you could see a lot of stuff is just free. A lot of people can learn. Okay. So here, so basically we're going to create, load data, query, and delete. That's all at the end of the day. That scope you understand, the steps will be much simpler. Again, for just to get into some of these things, right? Why Amazon DynamoDB people use? Just get some context. So at least my experience when I did Amazon AWS labs, I didn't even spend a minute on this, spend even a second. I simply, because I clicked on lab, there is a 40 minutes, I'm just clicking the clock, and keep on going. Oh, I have to finish it, I have to finish it. But then I realized end of the day, I don't know what I did and why I did. Then I realized, we need to spend some time on this. It's not, we should know what is, everything is given here, but we just need to understand. So if you see Amazon DynamoDB, mainly it is a fast and flexible NoSQL database. So it's a service for all applications that need consistent single-digit millisecond latency at any scale. Some of this terminology follow very closely. These are the things that are not possible in regular traditional databases. It's kind of a definition itself. What NoSQL database is, why NoSQL database become an important thing when we have all these databases outside. Okay. First of all, it is fully managed database. It's like a service. Okay. And it supports both the document and key value data models. This is the biggest differentiator. If anyone know, when we say database, regular database, it maintains the tables in a structured format, and it's all data in a table structure and column structure, right? But when it comes to DynamoDB, what do you do? For example, I have a big XML document, right? Or I have some lot of documents, XML documents, or key value pairs like objects. And how do you store that in a regular database? Maybe you will put it as like a blob or a clob, something. But you will never be able to store that as a document or a key value pair directly. And why it is important to store them like a document or XML document or a key value pair, and what it will give you advantage? It is the flexible data model and reliable performance, because a lot of data nowadays, it's coming from not traditional database systems or regular web applications. it's coming from mobile and web, gaming, ad tech, IoT. So the type of data you're getting, you cannot expect always your data coming as a table, regular table or a file. It could come in any format, like a document, XML document, or an object, a key value pair of objects. So there is no need for them to, in general, if you don't have a DynamoDB or a NoSQL database, what do you do? If somebody give you an XML in the traditional database, what do we do? As simple as we will store that as in one column as a club or a blob, and then we write some PLSQL program to parse through that all the loops in the XML structure and find out what information in this hierarchy of the structure. But there is no easy way you can really understand the data in a simple query. But now NoSQL database allow you keep your document as it is, just store it and query it as it is. You don't need to do anything special, no parsing, nothing. So it allows you to store different type of data sets. Okay, that's the biggest advantage. That's why it became, it's kind of a RDBMS type of database on HDFS file system, because it can support any type of data, documents and objects and all that. Okay, so I think for the question that earlier Om asked, right, the DynamoDB, I mean the NoSQL database, that's an explanation for that, why NoSQL database is something different from the other databases.
Yeah, Keshav, we have been working on this kind of system for the last 8 years. This is a Goldman Sachs initially. Goldman Sachs has a concept called SecDB, you know that, right?
Yep. We had the same thing in Merrill also. Actually, Goldman only introduced that. Yeah.
SecDB, then it became Athena in HydraDB in JP Morgan.
Yeah.
Then it became
they call it as Quad, right?
Quad in Bank of America.
Yeah. They make it as a Quad in Bank of America.
Yeah.
That's the same thing. Basically, that's a custom build. So basically, NoSQL database concept, when it is introduced, when we did our big data project in Merrill Lynch, Bank of America, we exactly got Quad also at the same time. That's the in-house NoSQL database.
Yeah. So written by Harvard guy.
Yeah. So that came from Goldman Sachs. You're right. So that's exactly that's the time we were debating. When we have Quad, we are building Quad one side and in-house, and why we need to bring MongoDB and all other type of NoSQL databases at the time. We were debating, but there was a reason why we were doing, because Quad is already like it's handling so much of trade related Bloomberg and a lot of other stuff. It's already somehow there was a lot of influence from management to use that. Yeah.
Thank you.
Yeah. But that's exactly, so there is no even Quad or any other database that you mentioned. It is all started when this NoSQL database concept came only. They're all origin of that. And Amazon came up with DynamoDB, and there are a lot other, actually, so many products. Okay, so now enough talking. Maybe I have only 10 minutes left for this, but you can start lab. And what I will show is I'll use this remaining 10 minutes to show initial stuff, which if you don't have any issues with that, the rest will be simply following instructions. There is nothing much you need to worry. But initially, you might have an issue to get that some of the setup. Okay, and one more important thing, when you are when you start, right, always be aware of what region you are using. Okay, so when you start your instance, generally it will say something like US East, Northern Virginia, US East 1, something like this. So when you launch any new server, by default it will go to US East or global or something like that. So whatever it is launching, you make a note of it without missing, because you create your resources in one region, and then when you're doing a lab, you go and use some other service in a different region, they may not talk to each other. Okay, so a lot of people do that mistake. I want you to make sure that's clearly noted when you do. Actually, in the instructions also they mention that make a note of the AWS region, for example, this one, something like that. They already clearly give. If you follow instructions, you will anyway do all that. But if you try to skip some instructions, you may run into some issues, because some of these notes and instructions they mention, you will ignore, and then you will come back and say, oh, I am facing this problem, that problem. So you will actually spend more time if you don't follow instructions, at least first time. Okay. So now, so let me actually start this. So all you need to do is go up here. Where is my where do I do that? Yeah, I'm just trying to quickly check the few steps what we will do. And here I see, okay, you create a EC2 instance basically. Set up access, so create EC2 instance, and then yeah, go to DynamoDB, create table name, music, and all that. So I'll do this. Okay, adding modify table. That's okay. Yeah. So I'll just quickly do something, and basically you can take your own time. But what I wanted to make sure is actually some of the stuff it may not even really require putty for first exercise. I'm just wondering. You will see problem with putty initially for some people. That's what I want to avoid. Yeah, I don't see anywhere you need to use EC2 instance access directly. This exercise. Yeah. So everything happening on the UI. So you may not use putty on this lab. So that's why you don't need to worry. So you can simply start in parallel if you want. There is nothing that you will stuck really if you follow instructions. So let me also start. If any of you not at not having this account, you can watch and then maybe use this as a reference when you do. Where is that? Okay, you click on Start Lab, then it will launch. So it will have 40 minutes. Again, 40 minutes is more than enough. Nothing to worry. Time, don't worry about time too much. Usually, especially if it is free, don't worry, because since it is free, you can always restart again. But only thing, you will lose whatever you did. You may have to do again quickly at that point. So it may be frustrating if you really lose a lot of time. Generally, some people start and go out and come back, and then it's a problem. So when you start, just make sure you have at least 30 minutes in your hand. If it is 40 minutes, I would say not more than 30 minutes required. So after you click that, click on console. Basically, what it is doing right now, it is spinning off a server. Not server actually, it's going to actually AWS console right now. And this is how AWS console looks. Because you see some of these things because I already used S3, and otherwise you might see, some people might see simply like with a lot of services here without recently used any recently used things. You'll see from this block basically. Okay. So here on the left side here, you see services. You click on that just to explore what all the services we talked about earlier, right? Yeah, actually they categorize now. I mean, this categorization also will help you. So compute related, storage related, database related, all these things. So there are a lot of services here. We don't need to get into everything. Right now, for our exercise purpose, all we need to go to is DynamoDB. Okay. Click on DynamoDB. The one I am telling here, you see this on the right hand side, Oregon. That means the region that I am in right now is US West Oregon. Okay. Make a habit of this. Whenever you are working on AWS environment, always make a habit. When you launch any service, look at what region it belongs to. Okay. The reason for that, you want it to be aware of when you are working with multiple services, you try to make sure all of your services are under one region. The reason for that, if you don't, sometimes what will happen, without knowing, right, you simply create and you don't notice anything. And when I come back to services again, when you click, next time it may be different region. And you'll see, oh, I created something I don't see. You might create one EC2 instance in Oregon, and then you go back to services and launch again, look at all the dashboard. And that time, if by any chance, if the region is different, you may not even see your EC2 instance there. And you will surprise what happened to that. That's because your region is changed. It's a different region you're looking at. So you make sure always make a note of it, what region, and make sure always you're sticking to that region for all the exercise you're doing. I mean, in the real scenario, you don't need to worry about creating across regions, as long as they are in um, and if you are aware of what you are creating where, and you are able to communicate through them, providing the access to each other. Okay, so now once you create, basically in the exercise also, I'm sure that will be telling the instructions to create table, right? So here actually before you do, just look at down. These are various things here. You could create tables, add and query items, monitor and manage tables. Okay, creating a table, give some name. Let's follow the same thing maybe. Let's I would actually say go here and keep this in a different tab. So when you're going through this, you always have it handy, so it's easy, especially if you sometimes they ask you, name this way, that way, because in the exercise, this is a small exercise, so you don't really get that much of dependencies. But when you're doing a complex project, or some big task, so whatever name you refer here, and the later they'll use the same name, so you may confuse if you don't follow instructions properly. But once you are familiar with all this, you can give any names and doesn't matter. But you still need to remember, right? If you create something, a table, you should remember the table name. Otherwise, you cannot query on the same table name. Okay, so here I'm trying to use same, because that way you can see the same results, are just to verify things are working. So just give the table name as music. Primary key is a type artist and select string. Okay, so I'll create the same. I'll say music. And this is artist. Primary key. String. I think that's the same thing they maintain. Yeah. Add a sort key in the new field type, song title. Leave string selected. Okay. Add sort key for the song title. Okay. So song title. Type is string. So basically what you're creating, if you see, you're creating a table and you're defining some basic keys and sort key and partition key, things like that. So which will create behind the scene, it will create a metadata structure in the DynamoDB. Okay, so the biggest difference, remember again, the data will not be stored like table columns here. The data will be stored like key value pairs. What that means, you will have a key for, I might have like hundreds of keys, and each key will have a value, key value, key value, key value, like that. That's how it stores the data. Okay, if let's say I have to have 100 names to be stored, like first name, last name. Usually we store it in a 2 columns, right? With 100 rows, saying first name, last name, and 100 rows. You will give Keshwara and Om Naka, like you'll give like 100 rows. That's the structure you maintain. But when you think of a key value pair, it will store differently. It will store key value, right? That means it is not going to keep the first name, last name as a. It's going to say the structure of key is you have a every name is an object. Okay, every name is an object which will have a name as it's like a column oriented instead of a row oriented. Generally data is row oriented, right? So when you do a key value pairs, what will happen? Your rows become column. I would say rows become columns, but if I have an object, right? If I have to create 100 people, 100 rows. Let me show here. Maybe I should have a slide also on that to show it better. Actually, that would cover in the next slide, but I'll just bring it up so you will know.
Yeah, sorry, Keshav garu. So where we can find the time that is remaining and
What is that?
time for the exercise, like time for the completion, time left.
That will be there on the screen itself directly. You have it here on the. What is that? Yeah, when you're doing the exercise on the top. No, because now I am already into this. So yeah, here when you are on the first page, right, where you are doing, you'll see this on the where. Just go back maybe wherever you started. I think if you are into the content, just go back to that again.
Yeah. Okay.
Yeah. What I'm trying to show you some difference in understanding of a column, right? Data, how it is maintained, because it's to make it visual, it is better for you. Yeah, right there. This is what I want to show you. Think of this way. See, generally, this slide is very important. Fundamentally, it's a radical change in the way of how people think to store the data. Okay. I mean, again, HBase itself is a NoSQL database for native Hadoop platform. Okay, whether it's NoSQL database, MongoDB, DynamoDB, doesn't matter. They're all following HBase concept. HBase is nothing but another NoSQL database in Apache Foundation. Okay, so think of this way. All we used to think so far is column 1, column 2, column 3, row 1, row 2, row 3, like that, right? You keep, let's say, the first name, last name, email, whatever, like that, and you put like row 1, okay, Keshav, Andy, his phone number, email, like that. So you store that way. This is how we used to store the data in the tables and database. That thinking has to change when it comes to the object uh, key value pairs data documents storage. You have to start thinking like this. You will have rows, but each row will have column A and value, column B and value, column C and value. And again, I might have a row 2. It is totally different column. I don't need to have the same column in the column A column. My row 2, so let's say, let me put it this way. My first row could have 5 columns. My second row could have 10 columns. I don't care. The reason for that, you are not depending on a row column format anymore. You are storing your data like a number of rows. In each row, you could have number of key value pairs. Understand, right? It's like objects. You're storing in row 1. I can store 3 columns, like column A and its value, column B and its value, column C and its value. In the row 2, I can say completely different columns, or maybe some extra columns or less columns. That is why it is important to think this way. When you get the big data, which is basically mostly big data, nothing but like unstructured data, it may not have the structure like you were expecting earlier, like number of columns and rows fixed. Always you get the data for these 3 columns in a row, like that. It's not like that. And these columns could be totally different in my second row. And there is no structure for the data I'm getting. If I'm getting a file, some data dump coming from source, some sensor or some IoT, something sending me data, I cannot expect that is giving me row 1 like from column like up to from starting 1 to 10 characters is column 1, 10 to 20 second column. It's not a fixed format. It could be totally different content in the next line. You don't know what it is. There is no structure. So this way, if you store data, it doesn't work for big data. It works for structured data. Still, big data platform can be used for both structured, semi-structured, unstructured, any type of data. But regular traditional systems cannot support everything. So the new systems, all the NoSQL database, Hadoop systems, all that, they're designed in such a way you could get any type of data, whether structured or unstructured, doesn't matter. It should be working. So that's why thinking of how you organize the data. It's not the data how it is. How you organize the data makes difference. So this is the thinking we are getting into.
Yeah, it is for the computer science people, for the who are in the computer science undergrad. You heard about the hash structure, how the hash structure is stored the data.
Exactly. Yeah.
And that's why it is able to in the hash structure. The time complexity to set the data is it constant. Even you have 1 million rows, 10 million rows, 1 billion rows, the setting the data is at a constant value. So that is the reason this faster sets, as Casher said, searching the data, you can get instantaneously you can get the data using this time complexity, that login. I think login is not login. What do you call it? O login. So it's it's constant time to access the data.
Yep. That's exactly. Yeah, I think it's like a hash mapping.
This is what Google file system they thought when hash structure can be stored with key value page. Why can't we store data, every data like that, and hash structure you can set the data with constant time.
Yep.
And we can do the amazing wonders. That's the idea. Simple hash structure idea. They made billions now.
Yeah, simple. Really, the concept is there even in the C++ compilers and all the way back. It's there for a long time. Hash mapping and all, the key value pairs. But that's what they exactly, because they have a need to do that. Like Google has a lot of data coming in the text search, right? Google Analytics and Google Search. So it's all like there is no particular pattern like how people search, and it's all text, and there is no easy way for them to store all that in a proper structure. So they have to just go with the key value pair model. And that's when they started inventing, what to do. This is how the solution came finally. So anyway, so we'll get back to some of those fundamentals tomorrow. But I know we are already 10 minutes over, but still in the lab is still happening. But what I would do is here at this point, don't want to hold everyone. But whoever want to drop off, you can drop off, and whoever want to continue, you can continue on your own as well. But if you want to stay with me, I can finish maybe another 10-15 minutes. But there is nothing special that you need to really wait and do. You can always do even tomorrow morning or before you come to next class. This can be very easily, if you follow the instructions, there is nothing really new here. Especially I don't see any complexity. This is one of the basic and very simple exercise which will allow you to do basically creating table, right? Once I create, you'll see. Actually, let me quickly do that actually. So it'll just create a table structure, and then so you'll see the table name here. It's being created still, so it's a little bit slow. Maybe my network here. So basically, it will show you like how the structure will be, what we created. We can create basically structure itself. So here, when I go back to the content here, what they do, yeah, it'll allow you to create new attributes. Like you can click on keep on appending various attributes, and what type you want to give for the attribute. It's like creating columns basically. All you don't need much columns here. All you need is one is a key and one is value. Key value pairs, right? So you don't really have multiple columns. So that's it. I mean, here you create like this some of the attributes, right? Artist, song title, album title, year. So once you create, Yeah, and then modify existing table and put some data and query. It's all like a UI driven. Again, don't think NoSQL database or DynamoDB is just creating everything through the UI. Okay, so in a real environment, you might even see something different scenarios, because some people may not even have UI access, but in the backend also there is a command line way of doing things. But in this case, we haven't created instance and we don't have access to the Linux server, so I may not be able to show the commands here for that particular scenario. But when we create a real setup, right, like cluster nodes and all that, which we'll be doing in some of the exercises, then I can show what commands can be executed, right? For example, DynamoDB has its own commands, basically, create table and all this. You can do that on the backend. It doesn't need to be always done through the UI alone, but it's easier for people who don't want to go to the backend and do command line work. Some people like just doing it on the UI. There is no like good or bad. It's just preference. Okay. So yeah, I don't know. I mean, I can go through all these steps one by one and do myself, or I would let you guys do actually. That way, you have at least you get some familiarity with the system, like how to look at this, some of these basic things, how it looks finally. Okay, so I may not, and there is no point in myself doing, and I would let you do and see if you have any issues or questions. I'll stay here maybe in another few minutes. If people want to leave and you have to go tomorrow morning or something, then feel free, and you can do even tomorrow before 8, because we'll meet again tomorrow 8:30, so you'll have enough time. Somewhere you find some 30 minutes, you can finish it before you get in. And if you want, we can take first few minutes to discuss if any issues tomorrow. Okay, so with that I will leave here. I will let you guys finish, and I'll stand by here and wait for any questions or anything. But today, since we are running a little late, this 20 minutes, I would leave at this point. Okay, any questions you want to discuss? Any specific questions or anything from the topic today in general, or you want to digest and come back with questions tomorrow? Usually that's what I do. Whatever topics we discuss today, some of the discussions are happening. If you can think through and digest that, right, for a day, and tomorrow when you come, before we start our session, I would like to start with questions that comes to your mind based on what we learned from yesterday's class. So that way you went through and you sleep overnight thinking about some of these things, and you might get some questions and doubts. So that will help you clarify with the team. All right. And yeah, with that, I think I would leave it there. And let me
good, Andy. It's very nice. We learn a lot. At least the cloud, how is the cloud and everything, different components. Everyone is talking about it.
Right. Yeah, I'm sure every day will be something new and a lot of new terminology coming into your way. But hopefully, how much of we digest and how much of we use it will finally makes us successful in this. Yeah.
Yeah. Thank you.
Okay. So good night all, and one reminder for everyone, the session will be anyway, once I close this session, it will be recorded and available on the YouTube channel again. So in case even somebody miss, I'll try to make that link separately and send out for all the same emails, I'll send out as a link. So you keep that as a reference. So that way, even in the, after a couple of days, whenever you have some time, if you want to replay and just to go through this discussion, some of these points, right, what we're talking. So right now you feel like you understand, but you may want to revise and look at this again. So you can always refer back to that.
Yeah.
Makes sense. Okay.
Any questions, Vivek, Durga?
Please feel free to raise any questions or anything on top of it right now. Yeah.
Okay, Kishore garu unnattu.
Sure, sir. As of now, we don't have any. But when we practice, I think we'll get some.
Exactly. Yeah. So especially when you practice, if you get issues, feel happy for it. I'm telling you, because people who get more issues during the practice, they are more experienced. Basically, you get more
Yes, sir.
experience, and you will be. Whenever you get the similar problem next time, you're already experienced. That's the advantage. So don't worry getting problems.
Yeah.
Never afraid for getting the problems. Facing the problems is always take as an advantage.
Yes, sir.
Okay.
Sure, sir. Once we practice, I think we'll get some points to discuss.
Definitely, yeah. And definitely one other thing I will start doing is I will send out this reference book, all the links that I showed you, all that. So maybe I'll put it into email. So what will happen, there's a lot of documentation actually, if you guys can go through even before we start. At least I'm going to explain anyway a lot of these concepts, so a little more deep. I don't know if you can find everything in the documents here, but a lot of these are very standard documents from available everywhere. uh, Sometimes it is too much to digest all this first time without somebody explaining. So that's why I will leave it generally for this to at the end. So once you learn all this and then you go through this, then it will connect better. But if you really want to went ahead and go ahead and do some things, you can always feel free. I'll anyway send those things out.
Kishore, this Kishore.
Yeah, Kishore, tell me. Yeah.
This set చేసేటప్పుడు we don't have option for case sensitive, right? I think we are same case లో ఇవ్వాల్సి వస్తుంది కదా.
What do you mean case sensitive where?
While querying the data, we had to give in the same case what we entered the data. Like if you put in uppercase, I have to search same uppercase.
That's because of the nature of how data stored in HDFS.
Right.
Yeah, it's really case sensitive. One thing need to be very clear. Even null. Null is in general, null is not a character, right? Null is not a character in regular traditional database systems, right?
Right.
Here, null is also a character.
Right.
So
okay.
you will see a lot of such differences, small things, because the way data stored and the data maintained in the file system is little different compared to traditional systems. So you will see case sensitive is one thing, null is one thing, very popular common issues people feel different than regular systems.
Okay.
Yeah, that's a good question. Very good question. Yeah, good observation. Okay. And one more thing, maybe I'll jump into some of the other things as we go, but because we have at least a couple of weeks, so there will be a lot we will be discussing. Yeah.
Okay, I'm leaving in.
All right. Yeah. So good night all. Let me know if anyone wants to stay for. I can definitely at least another 10 minutes. I can be here. But if no other questions and everyone is leaving, then I can drop off. No problem.
No,
okay.
I'm good. I think I can get back to you tomorrow before this session.
Correct. Yeah, but definitely make sure everyone finish the lab before you come to tomorrow class. Okay.
Yeah. Yes, sir. Yeah.
So finish that, and that way don't keep any backlogs. That way, because every day we will have something new to learn and new to practice. So I don't want to get any backlog because of today's time delay.
Yeah.
And I would like to start 8 actually. That way that's what I thought actually, 8 to 10. The reason I put it, I thought we can do 2 hours, and even if we need to take some extra 30 minutes, that will cover up. But since we're starting 8:30, so it may be too much stretch for people to be there till 11. So at least every day it's work days, right? So
yeah, actually, it's better to start by 8 if possible.
But I think Nageshwar, Omgar, you want to check with him? Maybe I know he is the one actually asked me, but I don't know if looks like other people may be able to make it.
I think Omgar left and.
Oh, okay. Oh, I didn't see that part. Okay.
Yeah, and actually we once again can check in the group if everyone is okay on starting by 8, then.
Yeah, so let's I'll check it offline, Andy. Let's see if that helps. I think that way, you might get like some extra time in the end, even if you want to extend to 10:30, like that. Otherwise, I mean, 11 will be stretch for a lot of people. So yeah.
Yeah, actually, dinner good cheyali.
Oh my God, sorry. Yeah, definitely make sure you finish dinner and come. This
Yeah,
will
I
be,
will try. Yeah.
because, yeah, every day, because I know it's not one day, right? So we have to go for a couple of weeks, right?
Yeah.
So I just want to make sure, yeah, finish all your dinner and other things before 8, definitely.
Yeah, sure.
These things will not stop. It's continuous marathon.
Yeah.
Okay.
Yeah.
And yeah,
Yeah.
I'll try to make it a little more interactive also going forward. But I know initially it's more one way, because a lot of stuff I have to give background and explain basics. But once you get into next levels, it'll become more a little bit discussion and interactive things. Yeah.
Yeah. Sure. Yeah.
Okay.
Yeah.
All right. Yeah.
Okay.
Thank you
Yeah.
all. Yeah.
Okay.
Have a good night.
Yeah. Thank you.
Right.
Yeah.
Good
Bye.
night.